Hello, everyone, and welcome to today's Career Development Series webinar, Optimizing the Lawyer Brain to Improve Well-Being and Enhance Performance. The ABA Career Development Series is a monthly webinar series that contains practical tips on job search and professional development issues for seasoned and new lawyers alike. The Career Development Series is brought to you by the ABA Career Center. The ABA Career Center offers both career development resources and a job board where you can upload your resume for employers to search and create job alerts based on your search preferences. All of this and more is accessible at ambar.org/careers. Moderating our program today is ABA Career Center board member Judith Gordon. Judith is a facilitator, mediator, coach, and founder of LeaderEsQ, a consultancy devoted to providing high achievers with the mental and emotional fitness tools they need to improve productivity, performance, and personal satisfaction. Her programs and coaching focus on building a sustainable career through leadership, resilience, emotional intelligence, stress management, and well-being training. That being said, we'll let Judith introduce today's panelists.
Thank you, Lexi and Emily, and happy Friday, everyone. I'm delighted to introduce Dr. Austin today. Dr. Debra Austin teaches lawyering process, advanced legal research and writing, and professionalism and well-being skills for the effective lawyer at the University of Denver Sturm College of Law. Debra writes and speaks about how neuroscience and psychology research can improve the well-being and performance of law students, lawyers, and other professionals. Debra earned her Bachelor of Music Education at the University of Colorado at Boulder, her JD at the University of San Francisco, and her PhD in education from the University of Denver. I am personally grateful to Dr. Austin for her work, as her research and scholarly articles have been foundational in the course that I teach at UCLA Law on Thriving in Practice. With that, I give you Dr. Austin.
Hello, thank you so much for your time today. I'm going to take us through a great deal of neuroscience and psychology research. The recommendations are all at the end of the PowerPoint, and then I will make available a Word document with the detailed recommendations that you might also find helpful. So in the lawyering profession, we are interested, those of us who write in the well-being area, to enhance our well-being and move us into the thriving, not just surviving area. The research is pretty grim for law students and lawyers. In a large study of over 11,000 law students, we find that law students binge drink at higher rates than other graduate students. They also suffer from depression, anxiety, and suicide risk at higher rates than other populations of graduate students or of people in their age group. The law students at Harvard asked for their well-being to be surveyed. There were 886 participants. The Harvard paper described the results as grisly. These statistics tracked the other research at about the same rates of high rates of depression, anxiety, and suicide risk, and 66% of this student population reported experiencing a new mental health challenge just since starting law school. So we would like to think that things get better in law practice, but the research indicates that's not the case. In another large research study of nearly 13,000 practicing lawyers, we see in the research that 23% qualify as problem drinkers, as compared to just under 12% of other highly educated professionals. We also see similarly high rates of anxiety, depression, and stress, and suicide is fourth. We are fourth in suicides behind doctors, dentists, and pharmacists in the profession. So the ABA took note of this well-being problem, formed a task force, and released a report in August of 2017, stating that we really want, as a profession, to enhance the effectiveness of our organizations, but we're also concerned about professional and ethical behavior, and we wish to see lawyers thrive in 6 different domains. Now, the general recommendations from this report were that we are trying to reduce the toxicity in our profession by trying to eliminate the stigma associated with seeking help. We're not good as a population for trying to get help with our issues. We want to connect well-being to a lawyer's duty of competence. We think that all the stakeholders need more education on the well-being issues, and we want to strive to improve the well-being with small steps. So the legal employer recommendations are meant to help get more education out to the lawyer population by providing training and education, as well as encouraging policies and practices that support well-being. There are a number of professional rules that tie us, our competence, to what we can learn now from neuroscience and psychology research. And there's robust academic research to show that if law students and lawyers can learn well-being skills, it's likely they can enhance their performance as well as their well-being. So a number of large studies on high school and college students have shown that not only can well-being skills enhance standardized test performance, but also things like GPA, submitting homework, and then academic and well-being and wealth attainment as adults. So we're going to take a look at a number of different psychology and neuroscience research findings to enhance our understanding of well-being, and that's going to require us basically to science the crap out of this topic. So I will be quickly covering the following areas in this talk. I will be talking about some specific areas of the brain, how they work together for learning and memory formation, what the impacts of stress is on our cognitive capacity, and then automated habit learning, which is centered in the motivation and reward system, followed by a few neurodestructive conditions we should be aware of, the impact of nutrition on brain health, and finally, our recommendations for optimizing our brain and mind. So starting with brain, our brain evolved from the base of our skull or our spine upward into three functional areas. The bottom area is the primitive brain, and it helps us with breathing and digestion, heartbeat. That's not really the focus of the talk today. Today I'm focusing on our emotional brain and our thinking brain. So our emotional brain rests above our primitive brain, and then finally at the top is our thinking brain, and that's that wrinkly, walnutty shaped part of our brain that we think of when we imagine our brain. So there are a couple of key parts to our emotional brain that I hope that you'll remember about today's talk. One is the blue horned structure. We actually have two of these. Our brain is divided into two hemispheres, and we have two hippocampus on each side. And the hippocampus is our memory processor. And scientists learned about a decade ago that we can grow new brain cells in this area of our brain, which is really exciting because there's some things that we can do to empower that process. At the end of that is the amygdala. And that little almond-shaped structure is our brain's panic button. And that's where our stress response begins. So we'll talk about that in just a couple of minutes. A couple of other key parts to our emotional brain have to do with habit learning and how we form habits through our motivation and reward system. That's our ventral tegmental area, which produces dopamine, which inspires habit learning, and our nucleus accumbens, which is the target of dopamine and responsible for where we experience pleasure. The thinking brain that resides at the top is divided into 4 lobes, and those lobes are largely devoted to our senses. Finally, there's the unit of communication, or the brain cell, and brain cells, also called neurons, are shaped like trees, and information flows through our neurons in one direction. So our dendrite branches are where information flows into the brain cell through a long trunk called the axon and out the bottom of the neuron. When information is within our brain cell, it's an electrical impulse. But to travel from one brain cell to the next requires a chemical called a neurotransmitter. So information is flowing through all of our brains right now in electrical, chemical, electrical impulses rapidly from brain cell to brain cell. Our brain has a couple of superpowers. One is neuroplasticity, and this is the power to change our neural network with every experience, action, and thought. So any of the new information that you're receiving in this talk today is going to be changing that network of neurons in your brain. The other superpower is neurogenesis, or the birth of new brain cells in our memory processing hippocampus. Now I'm going to move into learning and memory formation in our brain. This takes a couple of steps, and we're in a profession that requires lifelong learning, so it's helpful to understand how memory is formed and consolidated in our brain. And the first step is called encoding. Encoding starts with the process of sensory information entering our brain. So in today's talk, information is entering through your eyes as you look at the slides, and it's entering through your ears as you listen to the talk, and that's coming into your senses through your thinking brain. Then the information travels two different routes. The first route is called the quick and dirty route, and this is devoted to survival. And this information gets routed through the panic button amygdala. And what happens here is this information is screened for threat. So if I'm out walking my dog and I walk over something, it's my amygdala that tells me if that's a stick or a snake and what appropriate behavior to take. The slightly longer route, the analytical route, takes information into the emotional brain through the hippocampus and accesses other information I have in my hippocampus to help me make a decision. So that's how encoding starts, as information traces come in to your brain through your senses. Then the next thing that happens is that information trace travels from the thinking brain to the emotional brain in the process I just described, and then back to form a loop to the same areas in the thinking brain as it came into your brain. And information travels for some 2 to 10 years through this neural loop from the thinking brain to the emotional brain. So when we're developing expertise, say that starts in law school, information traces come into our brain. We do reading, we go to class. This information is traveling through this neural loop. We take tests. We're accessing information from that neural loop. We take the bar exam. We specialize in an area of practice. Information is being consolidated in our brain as we rehearse it, as we access it, as we develop our expertise in a practice area, and then eventually fully consolidated information lets go of its relationship with the emotional brain and the hippocampus and is distributed throughout a network of neurons in the thinking brain in a place called the connectome. So as lifelong learners, we have to consistently access information from both our thinking brain connectome, which is where our expertise is residing, and new information in that neural loop in our emotional and thinking brain. So keeping all of these areas of our brain healthy is important to our cognitive capacity. What happens when we experience stress? Well, you probably all know from your own experiences that when we're stressed, we don't think as well. And the reason I learned is probably because we're suffering some damage to our memory processing hippocampus. So how does this happen? Well, this involves our autonomic nervous system, which is divided into two halves. We have the fight or flight system, which is devoted to helping us marshal resources to arouse us, to defend ourselves, or to escape from predators. And then we have the other half, which is our rest and digest system, and this helps us return to equilibrium, helps us regain our balance, our sense of calm. And these systems were devoted to help us deal with very short-term stressors. So that's also known as acute stress. Now we don't really have to get away from predators, but the stress we feel is mostly psychological. And ideally, we would be able to marshal resources to deal with something short term, a challenge like a challenging hearing, perhaps. And then our rest and digest system would return us to calm and equilibrium. So short term stress response is actually powerful and helpful. The problem is sometimes we get into a situation where our stress response does not shut off when we're under chronic, long-lasting stress. So maybe we have long-term problems, long-term financial problems. I argue in some of my articles that law school might be chronically stressful, and maybe some people in law practice experience chronic stress from law practice as well. So what happens when our fight or flight system stress response doesn't shut down? Well, in that case, we can experience damage to our memory processing hippocampus. So when we get stress in our brain, stress hormones can harm or even kill existing brain cells and also suppress that process of giving birth to new brain cells that we need in our hippocampus. And once our hippocampus has experienced enough damage, it actually turns on itself and begins to produce more stress hormones. So it can get into this pretty negative cycle of harming our own memory processor and our ability to recall and learn new material is obstructed. Our brain focuses on survival, and it makes learning new material and recalling things that we should know much more difficult. The psychological studies show that when we're under chronic stress, we suffer impairment in things like memory, concentration, and problem solving, math and language performance, but also things like motivation, curiosity, and creativity are also impaired. Scientists and medical professionals can see actual shrinkage in the brains of people suffering from depression, PTSD, repeated jet lag, and I'm going to talk about the importance of sleep a little bit later, and also substance users. And the brain shrinkage and memory loss that these people experience are also proportional to an elevation in stress hormones. So what we want to do is we want to empower our rest and digest system. We need to be able to help ourselves return to that equilibrium, turn off the stress hormones, and lower that stress response. I want to shift gears from intentional learning and memory toward habit formation. This is an automated process in our brain, and once we understand this, it'll be better. We'll be better able to understand why habits are so difficult to change. So this takes us back to the emotional brain, to the motivation and reward system. And we need to understand this by understanding the role of the ventral tegmental area, which produces dopamine. And dopamine has been a little bit misunderstood. It's been described as the transmitter of pleasure, but that's not exactly accurate. It's really the transmitter of repeat behavior. Where we experience pleasure is in a little place called the nucleus accumbens, and that's where we have little receptors that allow us to experience the pleasure. So how does this work? Let's say I have a particular type of chocolate cake that I love. When I'm thinking about this chocolate cake, maybe craving it, I experience that desire or that craving in my ventral tegmental area. My VTA responds by releasing dopamine, and dopamine travels to the thinking brain, other parts of the emotional brain, and what that inspires is arousal and activity. I want to go get that reward, and that takes me to my favorite bakery that has the chocolate cake. When I acquire the incentive, the chocolate cake, I get a little hit of dopamine, and my bakery gets what's called incentive salience. So that means that even if I'm not craving my chocolate cake, if my commute takes me by my favorite bakery, I get another little hit of dopamine, which would inspire me to return to the bakery even if I wasn't intending to. And that's the case with any bad habit. So when we are doing things that we know maybe aren't great for our health, like me and my chocolate cake, dopamine helps get us there. It helps us be inspired to go get that thing that we're craving. So motivation and reward is inspired by dopamine and the incentive salience that dopamine gives locations. Maybe it's just the freezer where my ice cream is, for example. When we experience reward or pleasure, that's in those tiny hedonic hotspots in our nucleus accumbens. But anybody who knows who's got a sugar problem out there, like I do, that the pleasure I experience when I'm eating the first scoop of ice cream is more than when I'm on, say, scoop 3. So once we kind of realize that, maybe that can help us make better choices with respect to all the kinds of things that we might want to be cutting back on. So now that you know that our motivation and reward system can basically be hijacked by various things in our society, you understand more why habits are difficult to break, because you are getting these networks of neurons formed, and they're more difficult to break once you have, partaken in the chocolate cake over and over again. So scientists have identified over 100 neurotransmitters. There are just a few on the screen here that I want to review. You can also see a picture of a neuron and what it looks like at the synapse, or the gap between neurons. So one neuron produces a transmitter, releases it into the synapse or the gap, and it docks with the receiving neuron. Dopamine, I've already discussed. Endorphins are those things that when we exercise make us feel better. Serotonin is implicated in mood, oxytocin in bonding. Glutamate is a primary activating and signaling transmitter that's very important to learning and memory. GABA is the neurotransmitter of calm that helps return us to equilibrium. And norepinephrine is another activating, arousal, intention, motivating transmitter. So in synaptic transmission, a neurotransmitter is released, and if it's an agonist, it sits on a receptor and activates it. If it's an antagonist, it sits on a receptor and blocks it. So drugs widely conceived are dopamine stimulators, and you can think of drugs as anything that we now are able to produce in high concentrations, like sugar, but also other types of drugs, including drugs of abuse. So I'm going to talk a little bit about a few of these on the screen and then move into food. So caffeine is pretty easy to understand. It has an antagonist that blocks adenosine. Adenosine allows us to fall asleep. Well, when we have a cup of coffee or any other thing that has caffeine in it, we're using caffeine as an antagonist to block adenosine, and that produces arousal and can improve our concentration and athletic performance. Alcohol is a mixed action drug. It's mixed action because it acts on multiple transmitters. We know that we have high rates of drinking in our profession and that it might be something we want to address. And so it's helpful to understand what transmitters are involved when we consume alcohol. So one transmitter is increased is GABA. Remember, GABA is the transmitter of calm, and that causes that sedative effect when we have a cocktail. Alcohol also decreases the activating transmitter glutamate. This impairs learning and memory. It prevents the birth of new brain cells in our memory processing hippocampus, and it does so at a pretty low blood alcohol rate. We get an increase in dopamine, which we now know inspires repeat behavior, and an increase in endorphins, which gives us the pleasurable effects of having a cocktail. Chronic usage at alcoholic rates shrinks our brain in a variety of areas. Comfort food, so foods with high rates of sugar and fat, also are dopamine stimulators. We get that wanting, craving, repeat behavior for things like sugary treats because of dopamine, and then we get the pleasure or liking when our opioid and endocannabinoid receptors are activated. So I want to talk briefly before I get into diet that can increase your brain health with a couple of neurodestructive conditions that we've learned about by studying dementia and Alzheimer's. So patients who've passed from Alzheimer's have inflammation and oxidative stress in their brains. So inflammation is helpful, it's important, it helps us respond to injury and illness, but if we experience chronic inflammation, we can get diseases such as heart disease, cancer, and diabetes, but we're also at risk for dementia and Alzheimer's when we have chronic inflammation in our brain. That can be triggered by high calorie meals, high intake of concentrated carbs, excess insulin, and being overweight. Oxidative stress is caused by free radicals. When we get too many free radicals, then we're at risk for aging, cancer, stroke, heart attack, but also, again, Alzheimer's. That can be promoted when we eat high protein diets. So one way to counteract that is by eating a lot of plant-based foods, because the antioxidants in plant-based foods neutralize the free radicals. And finally, there's glycation. When you get an HbA1c test at the doctor, what you're being tested for is the percentage of blood that is glycated. And when you get a 6.5 or above, you're at risk for diabetes because your blood sugar has mixed with your hemoglobin, and that's the percentage of blood that is glycated. And there's a lot of different things you can see on your screen that are implicated when you have highly glycated blood, but it's important to brain health, our brain cells, and our connections between our brain cells as well. So our brain uses a lot of our energy. It directly uses 25% of the calories that we consume each day, and our brain is inspired to invest or eat, not to exercise or spend. And the reason is that storing glucose fuels our brain. So those of us that are lucky enough to have plenty of food to our access consume about a pound of it a day in the form of carbs, fat, and protein. The problem is if we consume anything close to what's considered the Western diet, we're consuming too much animal fat and sugar and not enough fruits, vegetables, and fiber. So I'm going to talk about each area of our diet and then give you some suggestions in just a few minutes. So foods that supply carbs include fruits, vegetables, beans, grains, and dairy products. And we need carbs. Carbs get a bad rap. Carbs are directly responsible for fueling our brain. What we need to try to do, though, is consume them in whole form, not in simple form. This is what we traditionally consume too much of when we consume the Western diet. When we consume too many processed foods, we get too much simple carbs. So what you want to do is aim for complex carbs. You get the fiber and the nutrient benefit. You get to feel full without having too much calorie overload. Your tummy works better. And you want to strive to eat as many different colored fruits and vegetables as you can in your diet. So we have energy stored in our body, about 120 calories as glucose in our blood, so our blood sugar. That lets us do everything we need to do in our daily lives. We have about 400 calories that are readily convertible from glycogen in the liver into blood sugar. And then about 1,400 calories are stored in our muscles, and that lets us move our body around and do our workouts. Now, what happens when we eat a meal is our blood sugar goes up, and that signals our pancreas to release insulin. And insulin is just a signal that says we have too much blood sugar. We can move some of that into storage in our liver, muscles, and our fat cells. Now, when our blood sugar drops and our blood levels drop down, our pancreas says, all right, glucagon, tell our liver to break down some of its glycogen and maintain our blood sugar in our blood system. Now, under stress, epinephrine, also known as adrenaline, is released, and it says we are experiencing stress. We need to marshal our resources. We need more blood sugar to respond to whatever is stressing us, and we get this rapid flooding of blood sugar. So we got high rates of blood sugar during the stress response. Remember, this is supposed to be very short-lived, and so when we get this rapid increase, if our stress response doesn't shut off, we're experiencing high blood sugar on a kind of a continuous basis, which is not meant to happen. It's supposed to return to equilibrium, calm us down, and go back to a normal rate. But that doesn't happen when we're experiencing a stress response that doesn't turn off. Moving on to fats, we need fats. They fuel and protect our body. They transport certain vitamins around. But the problem is we have an unlimited capacity to store fat. Our fat cells can grow quite large. We can produce more. So we have to be concerned about fat. And I want to move us in the direction of fatty acids so we can understand a little bit about which fats are most healthy for us. So the most healthy fats are monounsaturated. The worst fats are saturated. You can see from the picture on the screen, a saturated fat is a chain of carbons saturated by hydrogens. And when you have a double carbon bond, that means it cannot be fully saturated. So monounsaturated fats have one double carbon bond, and polyunsaturated fats, which is kind of in the middle as far as health risk, has two double carbon bonds. So the most healthy fats we can intake are things like avocados, olive oil, and canola oil, which are monounsaturated. So we want to strive for that type of fat intake, and polyunsaturated is in the middle, and reduce saturated fats from animal products. Digging a little deeper still into essential fatty acids, we have omega-6s and omega-3s. And we need both of them, but the problem is we consume a more traditional Western diet, our balance is out of whack. We have too many omega-6s and not enough omega-3s. You've probably seen some commercials and maybe some products in your grocery store that are fortified with omega-3s. So that's the reason we seem to have too few omega-3s generally. So some sources are nuts, seeds, and fatty fish like tuna and salmon, and then fortified products in your grocery store. Brussels sprouts, kale, and spinach also have omega-3, and then you might want to talk to your doctor about a supplement. So some of the supplements that are very popular include fish oil, but people that don't want to consume animal products can get algae omega-3 products. And finally, protein. So protein is really important. If we don't consume enough, we slow our metabolism down, which we don't want to do. We get nitrogen in the form of 9 amino acids with protein. And we've been told that animal products are high quality proteins because they contain all 9 of those amino acids. But we can get those from plant protein as well. So soybeans and quinoa have all 9 of those amino acids, but a combination of beans and rice or vegetables and nuts also get you there, and you don't have to have them in the same meal. So what are the brain benefits if you decide that maybe you're inspired to improve your diet? Well, you can have improved neurotransmitter production, better connections at the synapse, which means information is going to flow better for you, and better birth of new brain cells. You can also reduce your risk of stroke, inflammation, oxidation, and glycation. And you now know that those are implicated in Alzheimer's disease. So I have a story that's empowering, and that it's never too late to start making great decisions that improve your brain. So some of you might remember Dr. Spock. He was a very famous pediatrician when I was a kid, and my mom had all of his books. He was extremely healthy as a young person, winning a gold medal on the Yale rowing team. But when he was in his 80s, he was really sick. He'd been exposed to TB, he had pneumonia. He went to his doctor, and his doctor said, you know, really the only thing you can do is go home and install an elevator because you can't move around your house and wait to die. And what saved him or improved his life at the end of his life was being a cheapskate, because he didn't want to buy the elevator once he priced it. So what he did was he eliminated meat and cheese. He became a proponent of vegetables and whole grains, and his health improved dramatically within a pretty short period of time. And he became an advocate for plant-based diets in his old age, living to be almost 95 years old. But the problem is, to some degree, each one of us experiences this addict brain due to experiencing concentrated products such as high sugar products, and then having our motivation and reward system hijacked by those highly concentrated products. So now you know that it's pretty difficult to break habits because of the hijacking of your motivation and reward system. So I want to talk a little bit about 3 diets, and then I'll move into some general recommendations for brain health. So the whole food plant-based diet is the diet that's the subject of the China study. And you can see on the screen what you're supposed to eat and what you're supposed to limit or avoid. And you'll notice in all 3 of these diets, processed food is one that you're supposed to avoid. This is an extremely brain healthy diet based on whole plants. Now, another great brain diet is the Mediterranean diet. It's been studied since the 1960s, has lots of whole foods, fruits, vegetables, beans, nuts, some monounsaturated fat, mainly olive oil. People on the Mediterranean diet eat a lot of fish, and they eat a limited amount of meat and dairy. Another diet that's very popular that can work if you're willing to shift a little bit away from meat products and toward more fish is the paleo diet. Also focused on a lot of good whole foods like fruits, veggies, nuts and seeds, and healthy oils. High protein does put a brain at risk from too much animal protein. So a person who likes this diet and feels good on this diet, I think could be successful and empower their brain health if they were willing to reduce meat and increase fatty fish. So what are some simple ways to improve your diet? One thing is to consider smaller, more frequent meals to maintain stability with your blood sugar. Another thing is to think about eating a big salad every day with as dark leafy greens as you find palatable. Dress it with olive oil. If you can add nuts, avocados, that is also a healthy way to get monounsaturated fat. As far as what to drink, coffee and tea are great. They both have antioxidants, and the antioxidants they contain vary. So drinking both is very powerful. And then snacking on a variety of nuts for enhanced antioxidant intake. As far as carbs go, you want to go for whole carbs, fruits and veggies. If you were to aim to eat a pound of produce a day, you could then maybe reduce some of the problem foods, like I have for sugar. You want to try to slash sugar if you can. That reduces your cravings. One thing that can give you the sweet flavor, but that doesn't raise your blood sugar, is stevia. As far as fats, you now know that it would be great to have monounsaturated fat be most of what you consume and try to reduce polyunsaturated and saturated fats. Increasing your omega-3s is a good goal to do better with that omega-6, omega-3 balance. As far as protein, I'm not really here to pitch giving up meat, but I am here to sell you on the idea that if you could shift a little more toward fatty fish and a little away from other animal products, that's probably better for your brain. A healthy portion now of protein is considered to be the palm of your hand. And also maybe considering shifting to a little bit of plant protein as a method of reducing animal protein intake. Some shopping tips. You've probably heard to shop on the outside of the store, and that's because the processed food is all on the inside aisles. And finally, it takes a lot of energy and time to chop up all those good whole foods, fruits and veggies. So maybe treat yourself to your favorite Netflix or television. If you're interested in increasing plant protein and cooking with plants, I have a few books that are great. Rip Esselstyn has 2 really nice books, and Mayim Bialik also has a really nice book. And both of these are about 1/3 of the kinds of information I've been talking to you about today, and 2/3 recipes. All right, now I'd like to move into the general recommendations for enhancing your brain and mental health. And I have 2 recent studies to help inspire you. So these were just from the fall of 2018. So just over 2,000 people from the Framingham Heart Study were surveyed, and they found that those folks who had increased stress hormones also had shrinkage in brain volume and reduced cognitive capacity. So managing our stress is key to maintaining cognitive capacity and brain health. And another study of sedentary adults over the age of 55 were divided into 3 groups: a control group, an exercise group, and an exercise and improved diet, and they used the DASH diet. The folks with the improved exercise and diet had the best improvement in cognitive tests. The folks who exercised had some improvement, but not as much as the folks who exercised and changed their diet. So what about exercise? When I say exercise, I mean anything that increases your heart rate. So that's as simple as a brisk walk. What happens is you get benefits in terms of increased blood and oxygen flow, an increase in rebalancing of some key transmitters, and then I'm going to talk to you about a protein called BDNF. So first, increase blood flow. So this is important to getting resources into your brain, but also eliminating waste. So you might have heard in the popular press that waste elimination has been found to be important in reducing Alzheimer's risk. So exercise can help with this. When we exercise or raise our heart rate, we also increase and rebalance dopamine, serotonin, and norepinephrine. So if you are somebody who has an exercise program and you feel good when you exercise and not so good when you don't, part of it is due to this increase and rebalancing of these important transmitters. Also, when you exercise, your brain produces something called brain-derived neurotrophic factor. BDNF is like miracle grow for important brain cells in your hippocampus. And this is a powerful benefit that you get if you can develop or recommit to an exercise program. A little bit about the importance of sleep and memory consolidation. So when we sleep, we experience REM sleep cycles. And you can see on the screen by the chart, it takes us about 90 minutes to drop from being awake down through the stages of sleep and back up to a REM sleep cycle. And it takes 7 hours to get 4 REM sleep cycles. Why are these important? Well, scientists have discovered that our neurons are very active in the hippocampus and amygdala during the REM sleep cycle, that our memory consolidation genes are activated during REM, and scientists think that it's during REM that we do our primary memory consolidation. So short-changing sleep short-changes our capacity to remember. When you shortchange your sleep, you experience a great degree of cognitive decline. You get a diminished capacity for thinking and remembering. And if you do have to have some short nights, if you can squeeze in a nap, that will benefit you and give you a little bit of your cognitive capacity back. And what about mental strength? So we want to become what one author calls an amygdala whisperer. We want to empower that rest and digest recovery capacity. And how can we do it? Well, one way is through mindfulness. So what mindfulness is it's really the capacity to be in the present moment and not worry about the future or fret about the past. And when we have a mindfulness practice, what we're trying to do is on a spectrum of capacity. So the very first objective of mindfulness is just to calm our racing mind. Next on the spectrum is to develop the poise and capacity to respond to things, not react automatically. Then with greater mindfulness, we can experience flow, which is that capacity to be involved in something and time passes and we don't really realize it's gone by, and achieve optimal performance and joy. So the research on mindfulness is very powerful. It improves many aspects of thinking and cognitive capacity, like processing information, concentration, and decision making. It also improves our physical brain health and reduces stress and anxiety. There's a short practice called 3 questions to help us focus on being mindful. And that's to ask yourself, what's the most important time? And the answer is now, because that's what we have control over. Who is the most important person? That's the person you're interacting with. And what's the most important thing to do? And that's to serve the person you're interacting with. Now, meditation is one way to enhance your mindfulness. And meditation is simply a practice where you focus on your breath. And when your mind wanders, you gently notice it, non-judgmentally, and bring your focus back to your breath. And it's a lot like exercise, that you get the benefits from doing the practice. Research on meditation is also very powerful. It helps improve productivity, attention, mood, compassion. It improves brain strength and brain capacity, and it doesn't take a lot of time. So students who practice for 10 minutes a day for just 2 weeks improve their scores on the GRE, which is what you have to take when you want to go to graduate school. Another thing that lawyers struggle with is pessimism. We get kind of trained to be more pessimistic because we focus on what are all the bad things that might happen to our clients in any given scenario. And by doing that, we are training ourselves to be more pessimistic. How can we recover some of our optimism? Is through a gratitude practice. So you may have heard of something called gratitude journaling. And this is where you might write down every night 3 things you're grateful for, or 3 things that went well during the day. And your mind can't really tell the difference between the things you're grateful for or good experiences and when you reflect upon them. But the neuroscience shows that you don't even have to write it down to have a brain change and a brain benefit. You can simply do a reflection. So I like to do my gratitudes when I walk my dog, because I get outside and I think, oh, I'm really grateful for my dog and getting me outside. And then I proceed to reflect on everything I'm grateful for in my life. One of the things you can do, a little gratitude practice, is just notice the things in your day that give you just a tiny experience of joy, like that first sip of warm coffee. Again, people with gratitude practices have great benefits. In addition to having more positive emotions, they accomplish more goals, sleep better, have lower blood pressure, and even experience significant longevity. Now, if you're interested in mindfulness, I have a few recommendations for resources. There's a great book called The Anxious Lawyer, and this is an 8-week guide. It connects mindfulness to law practice directly. If you're a sports fan, The Mindful Athlete is a great choice. And then the other 2 books by Chade Meng Tan. He was an engineer at Google, and he's written these great books, very accessible, very uplifting books. So any of these would be wonderful resources if you're interested in mindfulness. Now, if you don't want to take the time, there's a bunch of really great mindfulness apps, some of them free, and you can just get on there and start experiencing some guided meditations right away. And finally, there's yoga. Yoga is mindful movement, and it has a kind of a magical capacity to increase GABA, which is the transmitter of calm. And even though the most experienced practitioners, or those that practice the most, have the highest GABA increases, brand new yogis can experience an increase in GABA right away. So now that you know that habits are difficult to change because you're changing neural networks, psychology research has shown if you're willing to track it in some way, if you're willing to log it in some way, you do a better job at actually making those habit changes. So what I've challenged you with my talk today is to think about your performance plan. Think about maybe some habits that you'd like to change, something that you would like to do differently, and know that you would be empowering your rest and digest system, know that you would be empowering your brain health by making some of these changes. If this talk wasn't nerdy enough for you, my articles can be downloaded for free at my website, which is debraaustin.info. I'm going to also provide a Word document that might be easier with the recommendations, so you'll get access to that. And then I think there's a few minutes for questions, but I'm also happy to answer questions in written form if that seems easier for those in the audience. Thank you so much for your time today.
Thank you very much, Debra, for a really engaging presentation, very dense with a lot of awesome resources to follow up on. We just have a couple of housekeeping notes to cover before we end today's program. First, starting with As a reminder, attendees will receive a recording of today's webinar and a copy of the PowerPoint in a follow-up email that will be sent within 7 business days. We have some upcoming Career Development Series programs and some upcoming Career Choice Series programs that are indicated in the handout that is available for download now. For more program information updates, you can connect with us on our social media pages, and all of this information is at ambar.org/careers on our homepage. On our homepage, the leadership page you'll want to take a look at to learn more about who helps make programs like these possible, such as Judith, who is on with us today. We look forward to sending the materials out, and have a great weekend, everyone.